Hello there, everyone. My name is Maverick, and I'm your guys' UGTA for IEE380 this semester. And today I'm just going to go over some concepts that will be covered in the third midterm exam. Specifically, I will be going over the two sample z-tests and z-intervals, along with the two sample t-test and two sample t-intervals. So in this tutored concept video, I'm going to be going over some problems that may help you whenever you are encountering similar problems on the exam or just relative to your guys' homework. So yeah, let's just get started with the first problem. So this problem says we have two different formulas of an oxygenated motor fuel, and it is being tested to study their road octane numbers. It says that the variance of road octane number for Formula 1 is 1.5, and for Formula 2, we have that it is 1.2. And additionally, we have two random sample sizes of 15 and 20 being tested, and the mean octane numbers observed are sample mean 89.2 fluid ounces and 92.9 fluid ounces, and we want to assume normality in this problem. So for part A, we want to test both the hypotheses using an alpha value of 0.05, where the first hypothesis is the population mean 1 is equal to the population mean 2, and the other hypothesis being that the population mean 1 is less than the population mean 2. And both of these hypotheses are pretty much the same thing as saying, like, for the first one, H naught, being that the difference of both the population means are equal to 0, or the difference of the population means is less than 0. And so in this problem, we are given a lot of the relative information we need to actually solve it. First off, in this problem, we are given both the variances for Formula 1 and 2 being 1.5 and 1.2. Therefore, since the variance is known in this problem, we already know that this problem is a two-sample z-test because a z-test focuses on when the variance is known. So given that we have the variances, we know that this tells us that this is a two-sample z-test problem. And we can test the hypotheses by putting all of the necessary information into our calculator under the two-sample z-test function under stats. And I'm using a TI-84 plus CE calculator. So this is going to be under stat, under tests, and under number 3, two sample z-test, under stats. So in this two sample z-test function, it asks us for the standard deviation for Formula 1 and for Formula 2. It asks us for the first and second sample means, and as well as both the sample sizes. And additionally, we are testing that the difference of the population means is less than 0. So we will also put that into the calculator function. And so with this, we have the standard deviation for Formula 1 being the square root of the Formula 1 variance, which is in this case 1.2247. We have the square root of the Formula 2 variance, which is 1.0954. And these are both the standard deviations for this calculator function. We have the sample mean for the first sample and the sample size for the first sample, as well as the sample mean for the second sample and the sample size for the second sample, and that the difference in population means is less than 0. And so whenever we compute this function, given all of this data, we are left with a result of a z-value of negative 9.250 and a p-value of 0. Now, in this problem, we wanted to test the hypotheses using an alpha value of 0.05. And the outcome of this two sample z-test gave us a p-value of 0. Now, how I approach these problems when I go about hypothesis testing is that I like to use the p-value and compare it with the alpha value. So as we can tell, we can see that the p-value is 0, and this is less than our alpha value of 0.05. Therefore, as a result, since this resulting p-value is less than the value for alpha, we can confirm that we reject the null in this case. Now, if the p-value was greater than our given alpha value of 0.05, say that our p-value was like 0.1, then we would fail to reject the null. But here in this case, we reject the null. Now here we have part B, and this states that we want to calculate a 95% two-sided confidence interval on the mean difference road octane number, x1 bar minus x2 bar. And so this part of the problem actually just uses the same information as we did for testing the hypothesis. We are given all the necessary information to be able to find the two-sided confidence interval on the mean difference, and we can do this by using the two-sample Z-interval function in our calculator. And we can provide all the same necessary information, but additionally, we provide the confidence level of 0.95 since we're calculating a 95% two-sided confidence interval. So if we provide all this necessary information and press enter, we should get our desired interval of negative 4.484 all the way to negative 2.916. Now, moving on to question 2, we have the diameter of steel rods manufactured on the two different machines is being investigated. Two random samples of size 15 and 17 are selected, and the sample means and sample variances are 8.73, 8.68, 0.35, 0.40. And in this problem, we are assuming that the variances are equal to one another and that the data is normally distributed. So for part A, we want to determine if there is evidence that to support the claim that the two machines produce rods with different mean parameters. So immediately off the bat, given all the context of this problem, we can notice that there are two things that we notice. We are not actually given the variances for this problem. We're given sample variances, but not the population variances. So given what's known in the slides, whenever the population variances are unknown, this means that we are in the process of doing a two-sample t-test. However, but on top of that, with a two-sample t-test, you can have two outcomes. You can either have a pooled or a not pooled. What's the difference here? So whenever we encounter a pooled version, we are assuming that the population variances are equal to one another. However, with not pooled, we are assuming that the population variances are not equal to one another. So given the context of this problem, we are assuming that the population variances are equal to one another and that the data is normally distributed. So given this, we can immediately off the bat say that this is a pooled two-sample t-test, given that we do not know the population variances, however, we're assuming that they're equal. We're determining whether there is a difference between the mean parameters. So in this, there's not really a sort of direction. So we can structure our hypotheses by saying that the difference in means is either equal to 0 or it's not equal to 0. We're determining if there is a difference in mean parameters. So I guess what you could say is like the word different here is the keyword. Different meaning like if it's equal or if it's not equal. So to recap, this is a two-sample t-test. We know that it is pooled because of the assumption that the population variances are equal, and we are given all the necessary information to plug into our calculator under the two-sample t-test function under stats. So if we scroll down a bit further, we have all our necessary information. We have our sample mean 8.73, our sample standard deviation for Formula 1, our sample size, and then our sample mean, sample standard deviation, sample size for Formula 2. We are testing whether there's a difference in mean parameters. So we're testing whether the difference in means is not equal to 0. And we're saying that the sample t-test is pooled because of the assumption. So now if we plug all this information into our calculator, we get a result of a t-value of 0.22997, a p-value of 0.819, and 30 degrees of freedom. So as we notice in this problem, we're not actually given a value for alpha to compare the p-value with. But in this case, we can see that our resulting p-value is actually pretty large. And it's much larger than a standard value than a value for alpha like 0.05. Therefore, as a result of our p-value being quite large, we can fail to reject the null. But again, if we were given like a value for alpha and that p-value was less than that value for alpha, we could say that we reject the null. However, in this case, we fail to reject. For part B, we want to construct a 95% confidence interval for the difference in mean rod diameter. And this follows kind of the same approach for the two-sample Z interval. We're given all the necessary information. We know that from the previous problem, it is pooled, and we're given a confidence level of 0.95. If we use the two sample T-Int function in our calculator and plug in all the necessary information from the problem, given our confidence level and our Boolean value for pool being yes, we get a result of a confidence interval of negative 0.394 and 0.494. And how do you want to interpret this interval? So whenever we get a resulting interval here and we're given a confidence level, we can state that we are 95% confident that the actual true difference in the mean diameters from the two machines is between these two values. So that's just the way of thinking about the interval whenever you get the corresponding result. It's just that given a confidence level, we can say that we are that confidence level percent confident that the true difference lies between these two values. So yeah, these two problems have covered some of the two sample inferences you might see later in homework or just in preparation for your guys' third midterm exam. If you guys had any questions about anything in regards to the material for the exam, feel free to join my office hours Tuesday, Thursday from 1:30 to 2:30, or just message me on Discord. My handle is WMAV or Godly. And thank you.